three categories of operator. Arithmetic first, plus, minus, multiply, and divide behave as you expect, and then there are two that need explaining because they have no everyday equivalent. Div is integer division. It divides and keeps only the whole number part, discarding any remainder. 17 div 5 is 3. Mod gives the remainder from that same division. 17 mod 5 is 2. Between them, they split a division into its two halves, and that turns out to be far more useful than it sounds. Mod is the standard test for divisibility. A number is even if number mod 2 equals 0 and divisible by 3 if number mod 3 equals 0. It also extracts the last digit of a number, since number mod 10 is whatever is in the units column. Let me show div and mod working together, because this is a genuine exam technique rather than trivia. Suppose you have a total number of seconds, say 3,725, and you need it as minutes and seconds. Minutes is 3,725 div 60, which is 62 whole minutes. Seconds is 3,725 mod 60, which is 5, so 62 minutes and 5 seconds. The same pattern converts pence into pounds and pence, or a count of items into full boxes plus leftovers. And it extends, to get hours as well, apply div and mod again to the 62 minutes. Whenever a question asks you to convert one unit into a larger unit with a remainder, div gives you the larger unit and mod gives you what is left over. That pairing is worth committing to memory. Relational operators compare two values and give a Boolean result equal to, not equal to, greater than, less than, greater than, or equal to, less than, or equal to. One point of pseudocode convention: the equal sign is used for comparison and the left arrow for assignment, which keeps the two clearly apart. A distinction some real programming languages blur and students then carry into their pseudocode. And Boolean operators: and is true only when both conditions are true, or is true when at least one is, not, reverses. These are exactly the gates from topic 10, and they follow exactly the same truth tables. If a condition in a program is getting complicated, drawing its truth table is a perfectly legitimate way to check it, the same technique in a different context. Library routines are ready-written subroutines the language provides, so you do not implement common tasks yourself. The string ones first. Length of a string returns the number of characters in it. Substring extracts part of a string. Ucase converts to uppercase and Lcase to lowercase, and those two matter more than they look, because they are how you compare text without worrying about capitalization. If a user types yes, yes, or yes, converting to uppercase before comparing means one comparison handles all three rather than a condition listing every variation. That is a genuinely useful trick, and it appears in mark schemes. Substring deserves care because its arguments are the single most common source of wrong answers in string questions. It takes the string, a starting position, and then, this is the point, the number of characters to take, not the ending position. So substring of the word computer, starting at position 4, length 3, gives you PUT. It starts at the fourth character and takes 3 of them. If you read that third argument as an end position, you would answer MPU and be wrong by one character in a way that looks entirely plausible. Whenever you use substring, say the arguments aloud. From here, take this many, and check the position numbering the question uses, because some conventions start at 1 and some at 0. The paper will make it clear, and assuming without checking is how the off by 1 creeps in. The numeric routines: int returns the integer part of a number, discarding the decimal part. Note that this truncates rather than rounds, so int of 3.9 is 3, not 4. Rounds a number to a given number of decimal places, which is what you want for money, and random generates a random number used for simulations, games, and shuffling. 2 points examiners look for. Know the difference between int and round, because they give different answers for the same input, and a question may test exactly that. And when using random, be able to describe how to scale it into the range you need. a random integer from 1 to 6 for a dice roll, rather than the raw value the routine returns. One idea behind all of this, since a question may ask why library routines are used at all. 3 reasons. They save development time because you are not writing code that already exists. They are reliable because they have been tested by very many people over a long period. Your own handwritten string search will have bugs that length does not. And they make programs easier to read and maintain, since another programmer immediately recognizes what UCase does without reading its implementation. Notice this is the same argument as the subroutines in the next lesson, and the same argument as modular design in topic 7. Write it once, test it once, use it everywhere. Library routines are simply that principle applied by the language designers on your behalf. 4 things to take into the exam. First, div gives the whole number part and mod gives the remainder, and together they split a quantity into a larger unit plus what is left over. Second, substring's third argument is a number of characters, not an end position. Say from here, take this many. Third, use ucase or lcase before comparing text, so that capitalization cannot cause a false mismatch. And fourth, if asked why library routines are used, give the reasons rather than the definition. Save time, tested reliability, and readable code. And note the syllabus expects these exact routine names in pseudocode: length, substring, UKs, LKs, round, random, not the equivalents from whichever language you use in class.